So this presentation is going to talk about the median of a set of data, the quartiles, the interquartile range, and box plots. So we're going to see what all of those things are. So first of all, starting with the median of a set of data is the middle value. So for example, the shoe sizes of the class that's called MYP3. There are the shoe sizes there. They're not in any particular order, so they're just random, but we're going to put these in order from the lowest to the highest. Then we're going to count from the ends into the middle to see where the middle is, and the middle is at 39. So if you put everybody in order, the person standing at the middle will have a shoe size of 39 on this particular occasion. The median is 39. Another example, the shoe sizes of MYP5, a different class. So those are their shoe sizes. Putting those in order, they look like that. And counting in from the ends to the middle, we get two values in the middle, but that's no problem. We just take the mean average of the two in the middle, and the median is 43.5. So that's the median. We're now going to look at something called quartiles. So we've seen how the median is the middle value, or the 50% value. It's halfway along the data. The quartiles are the values associated with the people or objects or whatever they are at the 25%, 50% and 75% points. So once again, the shoe sizes of class MYP3, there they are in order with the median, the middle value, highlighted 39. So that middle value splits the data into a bottom half and a top half. I'm going to look at the bottom half, and I'm going to start counting in from the ends again to find the middle of the bottom half. And the middle of the bottom half is at 38. I'm going to do the same with the top half. The middle of the top half is at 43. So if you line all the people in the class up, the person who's 25% of the way along has a shoe size of 38. The person who's bang in the middle has a shoe size of 39. And then the person who's 25% further along, so they're 25% from the top and 75% from the bottom, that person has a shoe size of 43. So we call these the quartiles. The lower quartile, or Q1 with a little subscript 1, is 38. The upper quartile, Q3, is 43. And Q2 is just the median. So three values that split the data into 4 quarters. Here's the same again for MYP5. So again, I've highlighted the two halves. So the bottom half was up to the median, and then the top half was from the median and beyond. So counting in from the ends to the middle of the bottom half, the middle of the bottom half is at 42. So the lower quartile is 42. Doing the same with the top half, counting in from the ends to the middle of the top half is 45. So the upper quartile is 45, or Q3 equals 45. And then the median is Q2, the middle value. So the quartiles are those three values that split the data into 4 quarters. The bottom 25%, the next 25% up to the middle, the next 25% after that, and then the top 25%. So we're going to talk about something called interquartile range now. So there's the MYP3 data again, with the lower quartile, the median, and the upper quartile. And the interquartile range is a measure of how spread out the set of data is, and it's basically how far from Q1 up to Q3. So Q3 minus Q1 gives you the interquartile range, as it's called. It's basically how spread out the middle 50% of the data is. So on this occasion, it's 43 minus 38, which is 5. So the interquartile range on this occasion is 5. The middle 50% of the data has a spread of 5 shoe sizes. So all of that can be shown on something called a box and whisker diagram. So a box and whisker diagram, or box plot as it's often known, display the highest and lowest values and the quartiles for sets of data. So I'm just going to put some scaling on here. So I've got the shoe sizes along the bottom from 35 up to 47 I've put. And here is the box plot for MYP3. So it shows a lot of things. It shows that the very lowest value is 36. So that's the very bottom of this diagram. You can see lines up with 36. The very top of the diagram lines up with 45 to show you the highest value. And then the box in the middle is showing you the middle 50%. So it's showing you from the lowest quartile, or the lower quartile, up to the upper quartile. So you can see the box starts at 38 and goes up to 43. That's the lower quartile and the upper quartile. So the box in the middle is showing you the middle 50% of the data. And then you can see there's a line in the middle of the box that's showing you where the median is. So the median is 39. So it's called a box and whisker diagram because it's got a box in the middle and then kind of looks like a cat's whisker on the edges showing you the full range of the data. And here's the same thing for MYP5. So the lowest value is 38. You can see the very left of the diagram lines up with 38. The highest value is 46 at the very right. The box in the middle is showing you the middle 50% of the data. So from the lower quartile 42 up to the upper quartile 45. And then the line in the middle is showing you the median at 43.5. So this diagram, or these diagrams, are showing you a lot that's helping you to compare the two groups. It's showing you where the center of the group is, so you can see, generally speaking, MYP5s have higher shoe sizes, and you can see that, for example, from the median. But then you can also see that for MYP3, it's more spread out. So it's telling you something about the central tendency or the central position of the data, but also something about the spread. So, as I just said, box plots are good for comparing the spread and central tendency of two groups with each other. There they are again. So here we could compare MYP3 with MYP5 by saying MYP5 have larger shoes than MYP3, a median of 43.5 compared to only 39. The sizes for MYP3 are more spread out than for MYP5, an interquartile range of 5 compared to 3. And generally, very often, exam questions are looking for you to do those 4 things that I've just done in the comment there. It's looking for you to make a comparison of the central tendency of the data, so this group is bigger or more than that group. So that in kind of plain language, but then supporting it with a statistical observation. The median is this compared with that. And then it's looking for you to make a plain language observation about the spread. So this group is more spread out than this group, but then backing that up with an observation about the interquartile range. The interquartile range for the first group is 5. 43 minus 38 is 5. But the interquartile range for the second group is only 3. 45 minus 42 is 3 for MYP5. So 4 things. A plain language comment about the position of the data, backing it up with a comment about where the median is, then a plain language comment about the spread, and then backing it up with a comment about the interquartile range. And that will usually get you the marks in an exam question.